Okay, this is actually a problem where you're practicing partial fraction decomposition. So you want to rewrite this fraction right here to make it look something like this. You need to find the values of A, B, C, and D. Now I'm going to go to the last board here, show you what the answer looks like. And I graph both these functions on Desmos, and there's the value of A, B, C, and D. And if you enable and disable these two functions, row 1 and row 2, you'll see that the graphs are identical. So these are the values. How do we get to them? Well, the key is to set up this equation where this side equals this side, and then multiply through by this denominator for starters. Okay, so when you take that denominator times this first fraction, the 3x's cancel out. The factors that remain times a are x plus 1 times x minus 3, the quantity squared. Similarly, when you multiply that denominator times this term with the b in the numerator, the x plus 1's cancel out. You're left with the 3x times x minus 3, the quantity squared, times this term with the c in the numerator. One of the x minus 3's cancel out. So you have a 3x and x plus 1 and x minus 3. And finally, times the last term, both of the factors of x minus 3 cancel out. You're left with the 3x times x plus 1. Now, you could multiply all this together and then separate it into x, something with x cubed in front of it, something with x squared in front of it, etc., and equate coefficients, which we're going to do for C. But I thought I'd show you an alternative. Okay. For example, if you let x equals -1, all of these factors that have x plus 1 in them will become 0. So you can actually solve for B by letting x equal -1. If you let x equal -1, this is what you get. And so B equals 1 over 48. Similarly, if you let x equal 0, all the terms that contain the factor 3x will go to 0. And so we can solve for A. So we get 1 minus times -3 squared is 9. A is 1/9. And finally, if we let x equal 3, all these terms with x minus 3 as a factor go to 0, and we can solve for D. So there we've got A, B, and D. But there's no way to find C without equating coefficients. So what do we do? So there's what we have so far. And you can see down here, I've kind of done my scratch work. It's like scrap paper. But I multiplied these together and got this, plus 1/48 times 3x times x minus 3, the quantity squared. And C is what we don't know. So we got to take 3x times x plus 1 times the quantity x minus 3, and this is what we get. And finally, there's sort of what we get for the last term. Now, here's where we equate coefficients. And the key is that over on the left side, there's 0x cubes, there's 0x squareds, and there's 0x. So we can equate coefficients with either x cubed, x squared, or x. I chose to say, well, I'm going to figure out what the coefficients of x cubed are on the right side. So I noticed that if I distribute this 1/9, I will get -1/9 x cubed, and I'll have a bunch of other terms here, but I'm just going to focus on the x cubed. If I take 1/48 times this 3x cubed, I get 1/16 x cubed, plus a bunch of other terms. If If I distribute this c, I get 3cx cubed. Finally, if I distribute this negative 1/36, well, I don't get an x cubed here, so this doesn't matter. So the circled coefficients, they have to add up to 0 because we've got 0x cubed on the left. So there it is. This coefficient, 3c minus 1/9 plus 1/16 has to equal 0. And if you go to the trouble of solving for c, you get c equals 7/430 seconds. And if I go back to board 3, all that is another way to rewrite f of f. You're going to use that technique when you get to calculus. There you go. Hope that helped. If you have any questions, post a comment.